Ever wondered why you don't fly off when the bus starts moving, or why it hurts when you stub your toe against a solid object? Prepare to have your mind open to the fundamental principles that govern these occurrences and more. Welcome to the fascinating realm of Newton's laws of motion. These laws, birthed from the brilliant mind of Sir Isaac Newton, have stood the test of time, providing the foundation for our understanding of how objects behave in motion. They're not just theories confined to the pages of physics textbooks, they're an integral part of our everyday experiences. From the gentle pull of gravity keeping us grounded, to the force exerted by a speeding car, or the sensation of wind against your face as you cycle down a hill, Newton's laws are at play. So, without further ado, let's delve into the intriguing world of Newton's laws of motion. Ever noticed how it's hard to start moving a heavy object, but once it starts moving, it's equally hard to stop? This is where Newton's first law of motion, often referred to as the law of inertia, comes into play. This law tells us that an object at rest tends to stay at rest, while an object in motion tends to stay in motion. This will continue until an external force acts upon it. Think about a parked car. It won't suddenly start moving unless someone or something pushes it. Similarly, a car cruising down the highway won't just come to a sudden stop unless the brakes are applied. This law is all about resistance to change in motion. It paints a picture of how objects, whether still or moving, would prefer to keep doing what they're doing. They need a nudge or a pull, a push or a halt from an external force to change their state of motion. In essence, objects like to keep doing what they're doing unless something stops or redirects them. Have you ever pushed a shopping cart and noticed how it moves faster the harder you push it? This is a simple yet perfect example of Newton's second law of motion, the law of acceleration. This law states that the acceleration of an object is directly proportional to the net force acting upon it. So, when you push a shopping cart, the force you apply propels it forward, causing it to move. But that's not all. The law also states that this acceleration is inversely proportional to the object's mass. This means that if you tried to push a heavier shopping cart with the same force, it would move slower than a lighter one. It's like trying to push a boulder versus a pebble. The bigger and heavier the object, the slower it moves, even if you're applying the same amount of force. So, the harder you push an object, the faster it goes, and the heavier the object, the slower it goes. Ever jumped off a boat and noticed how the boat moves in the opposite direction? This is a perfect illustration of Newton's third law of motion, which tells us that for every action, there is an equal and opposite reaction. Think of it this way. When you jump off the boat, you are applying a force on it, pushing it away, but this force doesn't go unanswered. The boat pushes back with an equal force in the opposite direction, which is why it moves away when you jump off. This principle is not limited to boats and jumping, but is a fundamental law of nature. It's why rockets can move in the vacuum of space. They expel gases with force in one direction, and in response, the rocket is propelled in the opposite direction. So every force you exert on an object, it exerts the same force back on you. So, what have we learned about Newton's laws of motion? In our journey into the world of physics, we've explored the three fundamental laws that govern the motion of objects. The first law, known as the law of inertia, tells us that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted on by an external force. Then, we delved into the second law, the law of acceleration, which explains how the velocity of an object changes when it's subjected to an external force. The force applied is equal to the mass of the object multiplied by its acceleration. Finally, we examined the third law, the principle of action and reaction, which states that for every action, there is an equal and opposite reaction. Remember, these laws are everywhere around us, governing the motion of everything we see and do. So next time you're in a moving car or pushing a shopping cart, remember, you're experiencing Newton's laws of motion in action.